Hi, Stuart here. Today we're going to talk about secure coding for Node development. This is intended to be an introductory course covering security things and then diving into the world of Node.js and specific things for that. But before then, we're going to cover off on a few security basics just so we're all on the same baseline. Let's talk about the general case for making an evaluation of security. This is the methodology that we use and widely used in industry, so it's not an oddball thing. In order to talk about security, what we need to do is we need to break down all of the attack vectors or problems that you can have. Someone did this a long time ago. You can read all about it in Wikipedia. But they said, you know what? We can pretty much categorize all security threats into 6 fundamental categories: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And it turns out that our friends at Flat Icon have a nice set of icons for all of those. So these are the 6 categories of threats. And when we do an assessment of a system, we go through and systematically say, okay, this thing exists, and then this thing talks to this thing and this thing, and we make a little easy to read bubble diagram with lines connecting each of our system components. And to each bubble or line, we attach as many of these threats as we think exist. And there is a very nice free stride modeling tool you can download from Microsoft and use. And it's useful because not only does it let you draw these things very quickly and easily, but for each of the objects, it knows what the likely threats are and has a description of the threat in detail. It will walk you through addressing all of them. And to address a threat means to do one of 2 things: either fix it and then test that it's fixed if you can, or categorizing it and put a rating or ranking on it as to how dreadful the problem is. And in fact, that's what the assessment of each threat is called. We look at the damage, reproducibility, exploitability, affected users, and discoverability of each threat, and we figure out if we can fix them and what the must fix state is based on the overall potential awful outcome. And then, we have to filter that by business gets to weigh whether or not we want to prioritize that or not over something else. Generally, they're quite nervous about security, so their general instruction to us is fix it if you can, watch for it if you can't, and to put all of the things that you find or could find into your backlog and also into your RAID log. Your RAID log is your risk management log, and we talk about that in other videos. The idea that we want to do as a team delivering software to the business is look at the defense in depth model. That's the egg of eggs, a layer upon layer of potential security areas, places we can go and secure. And at the top, we have policy, procedure, and awareness, which is basically just what we're going to talk about in this discussion, where there's a place for everything and everything in its place. And we have shop standards, and we're going to talk about what the desirable shop standards for different kinds of things for Node.js as we go along. And then there's physical security. Probably not as big a deal if you're using the cloud, but if you have a data center or your own data center, someone needs to consider physical security, usually the infrastructure team. You have the all-important perimeter security, which are the web application, firewalls, NSGs, things like that. And then you have the network security tier that has places in it that you can secure against specific kinds of threats. By the way, you may not have all of these things. These are just breaking down some of the critical eggs into, smaller categories and grouping them. You can secure your hosts and the host system. What's a host system? Well, if you are using Azure, and let's say you're deploying to VMs and you have your VMs in a high availability group, that high availability group is the host system, and the individual servers, the individual VMs are the host. If you're hosting in Kubernetes, in Azure Kubernetes server, then the host system is Kubernetes and the hosts are the pods that your code will run in, and so on. And then you have the runtime that you sit upon, like in our case, Node.js, and of course the code you write. And then we want to secure the data tier, right? We want to secure the data tier by implementing row-level security and other security things. We're not going to talk about that much because it deserves its own video, and so stay tuned. The important thing is you can secure against a threat in more than one place. But what you want to do is make sure that you're coordinating with all the teams doing the securing to make sure your policies don't actually conflict, or in some cases are so overly strict your application doesn't function. And we're going to do a video about web application firewalls and other network and security things, and talk about, policy configurations and stuff in a future video. But this is kind of the beginner's introduction or refresher for most of you, I would imagine, about security in NodeJs. So we can't talk about web security without talking about our friends at OWASP. And OWASP is the nonprofit organization that many of us belong to. All of us here belong to it, and you should absolutely join. It's cheap. Support the voluntary organization of people who spend time doing research on security threats and writing useful, reusable snippets of governance and policy and producing reports about upcoming threats or the change in threat landscape. And we're going to talk about that because the OWASP top 10 is done every cycle of years based on, and they only change it if the threat landscape radically changes. So if the threats kind of stay the same, different variations over time, they tend not to change it, because when they change it, then everybody's got to pay attention and go, oh, well, maybe we need to recraft our policy in this area, that area. So they change it when it needs changing, and they don't change it when it doesn't need changing. They do update the notes and other things in it, so it is being continuously maintained. The OWASP Top 10 is a way of focusing particularly development organizations like ours and yours on the 10 things that we should really care about. So we're going to take a lightning fast tour through that, but I strongly recommend that you go to the OWASP site and read the top 10 article, and then it does have breakdowns for different runtimes. So it's got one for .NET and for Java and whatever. And of course, Node.js is what I've extracted for this video. And there's just so much good stuff in there when it comes to security. It is not the be-all, end-all, but one thing that I do trust OWASP about is when they say something's a problem, they are credibly saying it's a problem, right? There's a lot of noise on the internet, right? And if you want signal, OWASP is one of the trusted sources you can get signal from. Broken access control is, as it says, moved up. We're going to focus on the green bits in these slides. Essentially, this is someone can come into your site or API or whatever, and they could perform an operation or see data they're not entitled to. And you can see in the upper right-hand corner, we have the little icons from our friends at FlatIcon that's described. You can say STRIDE, and you can see which ones are credibility. And so if we have identity authorization or authentication bugs, by golly, that is number one with a bullet on the things that'll hurt you. These are in the order of the things that are either will hurt you the worst or are most likely to hurt you. Number two, bad cryptography. Let me just stop and repeat something that I have said in pretty much every video that I ever have made that talks about security, and that is, don't write your own cryptography. Okay? I don't write my own. I trust other people to write good cryptography and test the daylights out of it. So I trust RSA, I trust Microsoft, I trust Google. If they're the authors of a cryptographic algorithm, it's probably pretty gosh darn sturdy. And the people who are InfoSec professionals in your organization will keep an eye on what algorithms at what bittedness are burly enough to protect your code and data from bad actors. It's amazing how much damage can be done, for example, if one of your HTTPS certificates expires and you allow a fallback to HTTP, because now you've basically bypassed encryption on the wire, and that's a bad thing. Please don't use HTTP. Use HTTPS. SQL injection still is number 3 with a bullet. You'd be amazed how many times I've done code reviews for customers or on open source projects, and the first thing I look at is they're interacting with any kind of database or any kind of backend, whether or not they're using concatenation. We got some code examples later. The other thing is that they don't have cross-site scripting vulnerability middleware that is configured per the shop standard. Those are just incredibly low-hanging fruit. But if we train developers developers what to look for, and we have tools that go, no, then we're happy camper. Insecure design is a problem, and it's a potentially dreadful problem, but it's a really hard to find problem. What do? Well, the first thing is we make stride models, and we've got a nice video on stride modeling, and it uses the open source Microsoft tool, and you can go and watch that and know how to do stride model. But the other thing is that if you've got any code sections that are tricky from a security point of view, you are probably much better off using someone's well-proven library. A general rule of thumb there is for Node developers is if you've heard of the people who wrote it, or it's a trusted vendor like Microsoft or Google, the NPM library itself, when you run NPM audit on it, or you go to the NPM website and look at the libraries, there are no reported security bugs or awful things. When in doubt, don't write it yourself. Use a third party that is widely used and actively maintained. Right? If you go to the NPM site and you're looking at a bunch of libraries, throw out any of the ones that haven't been maintained in the last 12 to 24 months. Because if they haven't gotten any security patches in the last 12 to 24 months, or any pull requests in the last 12 to 24 months, which means new NPM versions, you gotta wonder if anybody still loves and cares for that code. And if they don't, you're just inviting a security problem into your house. Security misconfiguration. The only way to really know if you have a problem in this area is to have pen testing done. And I'll just say this. We've talked about separation of duties in other videos. An organization cannot certify or pen test itself. You should go to a reputable third-party source, an organization ideally that does nothing but security testing, and pay them whatever they ask to pen test. And then on the other side, make sure that your developer tool chain has security tools in it so that as you are coding, VS Code, which is what most of us use to code Node, is shouting at you when you do something insecure, at least the low-hanging fruit versions. And by going at it from both directions, we can do two things. We can prevent it happening in the first place because we have a tool chain that's shifted left that tells us about things before we even do a PR. And then we have the outside validation and verification. We've done the right things in the right way. It's amazing when I look at old code and the first thing I do is I go pull it and then I do an npmi, better yet npm CI. If you're working in Node.js and you're not using a package lock config, that is a bad mistake. It's really important to pin your components. We'll talk about that more. But essentially what we want to do then is do an npmi, and then we want to pay attention to the output. Likewise, we need to make sure the partners that manage our hosts are patching them on some regular schedule, and they tell us about them, that they patch, because my code worked yesterday and doesn't work today, and you do a lot of research and fussing around and realize that someone's patched the host you're running on and they broke your stuff. You can't have parts of your organization pursuing security in the absence of their other partner. It just doesn't work. Likewise, if you're running Node 16, current version's Node 22, that's a bad thing. And for Node and NPM go hand in hand. And if you're using other tools in the tool chain besides Node and NPM, make sure those are patched too. And if you're using things besides NPM and Node, make sure that somebody is still maintaining them. There are a couple of pretty famous tools that are no longer getting any love. And the problem is that it turns out they have vulnerabilities, and that turns out to be a very bad thing. I tend to be a let's be vanilla Node person, but if there are things that you absolutely love, just make sure your tool chain is secure as the same effort that you put into your environments and your code. We talked about this a little bit. One of the things that's really frightens the daylights out of me when I go and audit program is if they don't have automation to rotate all the different kinds of secrets that they have with logging and rollback and repudiation protection. If people are going into individual hosts and monkey patching the HTTPS certificate, you maybe aren't mature enough to have software that lives in the real world, because that's just blatantly awful. You need to have tests in your integration testing layer somewhere that try to make calls to APIs with bad or missing identity. Cannot have a mature platform unless you're at 80% plus automation against the surface of your APIs at the very least. UI automation testing is a whole different deal, which parenthetically I'm not that qualified to speak about, so I'll leave it to someone else's channel, TM. But I'll just say this, for teams like us, we live in the middle tier, right? And so we spend a lot of time making sure things are automated. And by the way, I have a video showing you how to wire up your Node.js so that it automatically generates the Swagger or OpenAPI 3 documentation. This is all part of a mature thing. And the other thing is that the existence of a token nonce or other security artifact does not mean that it's not a poison pill. If your check is if bang token, then no. Should you check for it to be null? Yes. But you should then go on to do some at least minimum cryptographical verification to make sure that it is in fact your token or nonce or security artifact and that it's still valid. It hasn't expired, that the checksums are okay, that it decodes properly, etc., etc., etc. It's astounding to me how many people have lovingly embraced containers, and don't scan their, say, Kubernetes and container universe. There's a tool called Aquasec that I really like. There are plenty of competitors. Other options are available, but I'm going to talk about this one because this is the one I have most experience with personally, and my peers like it as well. And make sure that security gets baked into your CI/CD pipelines and is, that you have a regular security program that scans every little thing. And every little thing is defined in the defense in depth egg diagram that we showed you earlier. So if you're wondering where you should poke your nose into the egg and make sure you have an answer for all of it, even if we've deferred the problem to someone else. Like if you're using Azure, physical security is done by Microsoft. One of the things that is really tricky in apps generally is observability. And one of the things that is scary is I go look at code and there's some sort of security process like token validation or whatever. There's no logging of the failure. If it succeeds, that might be too much noise, or you can set it to the debug level or whatever, so you don't see it in your logs, 4 billion times a day. But if you have a cryptographic artifact validation failure, that's an error. And among other things, the music should stop for that request, right? Not for the whole app, that's ridiculous. But for that request should be blocked and it should be logged. And then at the outside of our code and all the other layers, we need to make sure we have an observability program that covers all parts of the egg that we need to cover. Obviously, we don't need to set up a physical security thing if we're on, Google Cloud or AWS or whatever. And then partners inside the organization that deal with the infrastructure, you want to be confident that they have a surveillance program based on observability. So what is a surveillance program? It's observability plus action. If you just have logging and no one ever looks at it, then it's like not having it at all. You get a false sense of security. You feel more secure than you actually are. So you have, for each of these things, you've got to make sure someone is actively watching it on some regular schedule. Cross-site scripting is still a thing, and they're getting more and more clever, the bad people. And so, make sure your SS middleware is up to the task and that you are logging failures of validation. And then, for goodness sake, make sure that your infrastructure partners are, setting the security postures of your appliances. A firewall does no good at all if the default password is password 1 and no one's changed it. A couple times a year, there are these reports that come from very credible sources, right? We go to one of our favorite websites like OWASP or whatever, and we read all about, they just set a bot across or a worm across the internet and they were looking for unsecured appliances. And there's still a frightening number of them. I mean, it's just horrible. So this isn't your problem as a developer, but as a member of the delivery team to the business, you need to ask the question, what is your rotation thing on the appliances, and how often do you regularly patch the the proms and stuff like that, right? What is your program? And if you get an answer you don't like, especially none of your business, then you need to raise your hand and tell a business you have a concern. And they don't have to tell you, but they should tell someone. By the way, how often you patch should not be a secret, unless it's never, in which case I wouldn't disclose that, but I would fix it too sweet. So what can we do? This next section is practical things that we, as deliverers of business value via code, can actually do, right? This is where we get super practical. And this is gathered into a bunch of rules. Number one, and you know this, none of these are like, oh, wow, that's a revelation. At least I hope not. If they are, then you're welcome and go fix it. So don't trust inputs. Assume that all arguments passed to your code may be incorrect, particularly at the surface of an API. If you have a method exposed on your API of any kind, but for a web API via put, post, get, just assume that all the inputs are potentially malformed, and you should do some validation. And if possible, if the business behavior would be consistent, you want to provide rational defaults. This is true for your configuration surface as well. Don't just take an incoming configuration item at its word. At the very least, type check that if it's supposed to be a number or a date, that it is. If it's supposed to be some sort of string, then it matches the desired pattern. If you're expecting a connection string, it actually is a connection string. Because if not, you subject yourself to an injection attack. If someone has penetrated all those eggy layers and gotten all the way down to your host, you have big problems, especially if they can manifestly change the values of environment variables. They are very deeply patterned indeed, and you should just code defensively. I found a bunch of weird bugs where every once in a while inputs from somewhere come encoded, or they have like bad characters in them because whoever made the data file or whoever pasted in the text, cut and paste text into a text box is like the worst. You pretty much want to go through and whitelist the characters from any text field. So you can do it with a regular expression. You can say capital A through Z, some certain punctuation characters and nothing else. And you just strip out the characters and you log that you had to as a warning. Understand that regular expressions have their limits. So there are other validation engines such as Joy. We have an example. Now, again, other libraries are available. I found Joy to be very reliable. We use it in our own code for our open source projects and so on, but your mileage may vary. But be careful of anything that does validation recursively, because you can effectively, if it can be made to recurse indefinitely, you can blow up the stack and effectively have a denial of service successful attack against your code. And it's hard to know if things are using recursion or not. Do what I do. The thing about Joy is it's all open source, so I can go out to GitHub and go, oh, that's how that works. Any recursion? Nope. Okay, we're good. I can't tell you how many times I've had to teach new team members about, I can't believe how many times I've had to teach new team members that are incoming about question mark period, which is return a null if the thing that follows doesn't exist on the object. If the thing to the right of the period is not on the object, what you get back as a value is null. And then after you've done that, you can use null coalescence, so question mark, and set a default property, or you can just tell it to throw. You can channel a throw in the same line. And those are super easy to read. If person question mark dot last name question mark throw new blah 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 error, whatever your business error. Avoid TypeScript assertions. The modern practice, although it was put in for compatibility, you can declare variables with a bang. So instead of saying first name as string, you can say first name as string bang, which means I don't want nulls. But the problem is that if you do that, it makes problems in other places. So the modern thought for TypeScript is to use coalescence and existential check. The other thing is you can use clever strategies like schemas. There is JSON schema now. So if you have a complex object, you can validate it using a JSON schema engine. And you can do casting to ducks. And if the cast fails, it probably isn't a valid schema. And you can read all about that duct. And then we use Fastify a lot as our framework for doing APIs, REST of APIs. I like it. And Fastify has a whole family of plugins, middleware plugins, that can do all kinds of fascinating things for you. And the Fastify validator is definitely worth looking at because you can declaratively just say, this is the shape of the thing that I expect to be the input for this parameter. And the Fastify validator will do a lot of the heavy lifting for you. So it's definitely worth checking out. But you should have something. Some of these things. At least one. Test for evil. Write unit tests that pass in bad thing. By the way, the word nil here is generic for this is falsy in air quotes in JavaScript. Our team's just decided that using the word nil describes falsy things. We can say falsy too, but nil is the formal computer science definition of falsiness. And falsiness, as you know, in JavaScript is a bit flaky. It's better in TypeScript because TypeScript does a much better job of introspecting type. That's why TypeScript is a thing. But, you should write some anti-use cases. I see lots of code bases that only have happy paths. And a lot of those don't even have all the happy paths. They just have happy paths because this person liked writing unit tests and that person didn't. First of all, you should be made to write unit tests as part of your shop standard, and the people checking your PR should reject it if you don't have any unit tests, or your unit tests don't run. Or your unit tests run but don't test anything. If you're using Jest, for example, and you have a test and no expecs in it, then that's not great because, and if you're in some other library and they use assert, then if there are no assertions, that's not great. That's not actually a test. Fuzzing is a good thing too, like generate random data and make sure that the things we just talked about on the previous slides are there. And if a test fails, make sure the testing log has the input that was used to cause the test to fail so that you can then reproduce the test when you're fixing up your code to be more strict. There's no substitution for smart people with a certain bent, as they say, to help you write tests. And in most organizations, QA is not there to write tests against your code. They write tests against the user, the business requirement. The general rubric in most organizations is if QA finds a bug in your code and not a disagreement about requirements, you've kind of had a fail. And that's a little happy and a little sad. When I was at Microsoft, we had people who were writing tests against our code as well as the business requirements. And that level of, multi-layered defense is much stronger. It's just not as economic. So if your QA people are just in the business requirements validation business, then you need to be super strict on your project to make sure that the unit tests test positive and negative use cases and that everything has some. Some things are hard to test, but I'll give you a little rubric I've said before, and I get this from a testing guru that I just think is the greatest QA ever on the face of the earth. And his rubric is, if it's hard to test, it's probably wrong. Act rationally on failure. Some languages, like Rust, have a thing about errors. And their thing is panic is the best way to do it. And for system software, probably good. For business software, where a lot of our happiness comes from interacting with back-end systems and databases and users, and we probably should be a little more nuanced. But I'll say this, don't derive errors that don't derive ultimately from the error object. Because if you vary from that, the catch block doesn't work anymore. And that is no bueno. So, and then again, shop standard, you should be using TS doc comments in your TypeScript code. And the error that a function can throw should be part of the documentation for the function. Inputs, outputs, commentary, and exceptions or errors that are thrown by your code. This is the minimum thing that should be the stop standard. And you shouldn't disclose sensitive data. Johnny typed in a password of foo. The actual correct password is boo. Validation failed. No. If you have units of work that are trying to make calls over the wire, you absolutely, positively should have exponential reach wrapped around that. A lot of frameworks that do interactions with databases or storage or whatever have built-in exponential retry or some retry strategy. Use that preferentially. Be the DAO of the library. So go look and see if your library has exponential retry, and then make double darn sure that it's turned on universally. A lot of things, libraries that, for example, connect to SQL Server has this idea that you make the connection object at the top of the project with the correct configuration that you want, and then it manages a connection pool. And then when you want a connection as a developer, you go mysingleton.getConnection. Execute this thing or whatever. If you have to use one of the kind of generic retriers, make sure you understand the zen of that retrier and actually calculate your minimum and maximum retry range to make sure that the output of whatever parameters you feed it, like how many times, how much to wait in between, what the exponential delay is, should we have an initial delay, things like that, or you calculate what the real range in milliseconds is going to be. Because if you don't, you can have some pretty wild values, and at the opposite ends of the spectrum, you have something where the retry basically isn't just retrying because it's jamming the thing down the wire with hardly a break in between, and retries that are so long that the thing that called you will time out in frustration. You don't want that. So do some calculation. And then handle failure rationally. I have upcoming an entire video about the ideas behind Saga. It's kind of an architectural thing, but essentially you need to have units of work that are reentrant if they fail, so you can try them again and maybe they'll succeed. And then you need to make sure that if ultimately your failure mechanism or retry mechanism doesn't work, that you lovingly but securely tell people what the problem. Again, observability is great, but unless there's inspection, right, people actually looking at the output of the observability system, it's like not having it at all. Trust but verify. We need to collaborate with other teams to get things done usually. Now, on our little open source projects, there's a little tiny group of us, and we trust each other, and we've worked with each other a really long time, and we know who's going to do what to whom and why. But if you're in a corporate setting, you definitely should have a working written agreement with every single other team, particularly those outside your project that you collab with. And if you raise a security concern or you've done a stride analysis and you're like, what are we doing to secure this? It's being dealt with by the infrastructure team. They should be able to tell you in words of few syllables what they did and provide proof of work. And then it should be made blisteringly clear that this is their problem. You are their consumer, their customer. You promise to do certain things in certain ways. They promise to provide certain things in certain ways, not the least of which is SLAs and change notification and all that other stuff. Again, fodder for a future video. Our friend the raid log comes back. It's just, you can't wing it. You got to have some stuff in writing. And people got to sign up to own a particular risk or area. Never assume. Never assume someone else was doing it. Someone else is doing it. It ought to be written down, and what they're doing should be written down. Never assume that just because your code builds that it's secure. Don't assume constants will never change. I have this allergy to hard coding things. People are like, well, there's 20 environment variables, and I'm like, right? It's cool as long as the total volume of environment variables doesn't exceed the amount allocated in the kernel per process. And that's a huge number. And then, if you really want to get things be dynamically configured, like you want to make people explicitly fetch a secret before they use it, or fetch a configuration item because it could be soft adjusted, like logging level, right? You've just got to assume that that will change and that your code is capable of responding to that change, either by inspecting at an interval or getting an event that says you need to, regin this thing and reabsorb the configuration or whatever. And there's lots of good NPM libraries to do that sort of thing. Code defensively, we talked about that. There's some pretty basic things that you want to do when you're setting up a server and node. And if you're using, as we do, you're using a container, what we do is in the container initialization, we make sure that we set a whole bunch of these node parameters for the runtime to make sure that certain things are not ever going to be a problem. For example, the default timeout for a process is 0, which means infinity. That is no bueno. You probably want to set a rational timeout. And there is a whole article on the NodeJs site that walks you through step by step configuring the parameters for the node runtime for a non-production and production environment, and for the values, what the trade-offs are, and how to tune to that. Whoever owns the runtime in part of the environment, whether it's you or infrastructure or whatever, just make sure you're doing that. And I will say it again, please don't let things run on HTTP. Do some basic stuff. It's amazing how many times I see the fact that you could go and request, for example, the Docker file, because it ended up being there was no Docker ignore, and so it served up the Docker file. And so if you go in and you request the Docker file from the root of your container, and you have static files configured, it will happily serve it up. It will happily serve up your package JSON, and so on. So just make sure that certain files are not allowed to be served. And the easiest way to do that is do it as far left as you can with a web security, WAF security policy. And then one of the things that API gateways and reverse proxies and WAFs are good for is you can add and strip headers. For example, if there is no explicit caching header, you should add the default one, which should generally be no cache. Dive into these things, right? Do a stride model, see where all the problems could be, and then make sure it's getting handled somewhere, ideally as far to the left as you can. And then you've got to do, as we said before, you've got to do NPM audit. You've got to use third-party tools to look at your code and the third-party code. And one of the biggest things I see in a lot of frameworks, which is my pet peeve, even with something as good as Fastify, is that there is, because you, in some cases, set up wildcard matching, it is possible to get routed to impossible places, most of whom hopefully will 404. But Lordy, it is super easy to have that not be true. Use npm CI in your build. That means build from my package lock file. Don't allow monkey patching, blah, 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 blah. So these are all things that you should be doing that are just baked into your CI pipeline. Talked about that one. Code reviews. Are we following the best practice? Can we spot an anti-practice when it happens? Could a bug be used to exploit a stride vulnerability? If we find a vulnerability, we need to immediately figure out what its dread is. How could we write a test to check? Ideally a unit test, but in some cases you have to use an integration test. That's okay. Again, we want to be as left as we can, so if we can catch it in the unit test, that's better. What do we need to coordinate with QA? What integration load and other testing is needed? And what should we tell InfoSec? Because they're our buddies, our partners, so that they can do their due diligence and help us write better, more secure code. Handy code samples. The bang bang operator is our friend. It's an amazing and useful thing that's been in JavaScript forever. It works perfectly well in TypeScript, and it allows you to find faulty things faster. SQL Injection Prevention. We talked about this. Use the engine of your database middleware to do parameterized checking so that the type and data are checked on the way in. In some cases, you may have to stringify them. Please don't do concatenation. Here's an example of using Joy. I build a panel and I can do a validation and I can, brings whatever. The Joy website is great. Again, other packages are available. Your mileage may vary. This is my favorite retry engine. Notice that there are a bunch of things that I configure in my retry. Most of them are soft configured. And as a best practice for anything going over the wire with retries, you want to make sure that you have jittered, that is to say, plus and minus a little bit the next call. Otherwise, you run the risk of something called wavelets, and there's another video about that. So here's the retrier itself. Here's how you would just set it up. And then your thing will do the right thing, and we pass the backup configuration in all cases. Here's a nice simple library called Fuzzing, and you can set it up to test your functions. If the fuzzer finds something, it'll tell you, and you can see what the fuzzing results are. This will definitely let you sleep at night. We found a couple of simply awful bugs using a fuzzing library like this one. Here's another one. My name is Stuart. Thank you for your kind attention.